Established in 2004 and funded by the U.S. Department of Homeland Security, CREATE is an interdisciplinary research center based at the University of Southern California. Focusing on risk and economic analysis, the center comprises a team of experts across the country with the mission to leverage academic research for real-world solutions to homeland security issues. One of these projects is ARMOR.
ARMOR originated in 2007 with the LAX police coming to us with the challenge of the fact that they had limited security resources and they had to be deployed at LAX intelligently. And this is the question that is at the heart of ARMOR. How do we take our limited security resources and deploy them in an intelligent fashion?
Limited security resources prevent full security coverage at all times. Computer-assisted randomization of security operations can help remove repeated patterns that may be exploited by intelligent adversaries. To do this, ARMOR modernizes a 70-year-old theory known as game theory.
Game theory is a mathematical approach to solving problems that arise when we have two adversaries and each one wishes to maximize their gain at the expense of the other. We formulate these as mathematical games because then we can use the power of computers and mathematics to solve for optimal solutions.
A game consists of a set of players, a set of actions available to those players, and a specification of payoffs for each combination of strategies.
We see this every day in real life. For instance, when you go to a football game, you're going to see two people playing against each other in a game. And their optimal strategies are called mixed strategies. A mixed strategy is a randomization of the possible things you can do. By randomizing and being unpredictable, we're able to gain an advantage over our adversary. And this is what the ARMOR technology is all about.
ARMOR stands for Assistant for Randomized Monitoring over Routes. The algorithm at the heart of the ARMOR technology was designed and developed at CREATE and the University of Southern California by a team of engineers and researchers.
And by solving this game, what we get is an optimal allocation of our limited security resources. Specifically, where should the checkpoints be set up and when, in the case of LAX, or when and where should the K9 units be deployed, giving them a patrolling pattern which is randomized.
The most recent application, ARMOR Trusts, or Tactical Randomization for Urban Security in Transit Systems, is currently being tested and evaluated by the LA Sheriff's Department.
So we were approached by the Los Angeles Sheriff's Department for randomizing patrols on trains for counter-terrorism, for suppressing crime, and for catching ticketless travelers on trains.
We learned about the ARMOR project, which was initially deployed at the airport, and we saw that the ARMOR project would likely have utility applied to the transit system, both bus and rail.
The Los Angeles Metropolitan Transportation System, Metro, serves over 10 million people a year throughout the Los Angeles basin and over 80,000 passengers a day. With that amount of ridership, it's impossible to police more than a fraction of the trains and cars. ARMOR models all possible paths through the system in space and time as mathematical operators that represent when and where a passenger boards a train, how many stops they remain on the train, and where and when they exit. Then, they superimpose on this passenger flow model another model of police actions to determine which trains to board or exits to monitor.
So the first step here was immersion. This is a critical step in any of our deployments. We go out and immerse ourselves in the environment that the security teams operate in this case, patrolling on the trains in Los Angeles.
So when we started the project, the CREATE project team came to visit us at the Sheriff's Department. We shared our historical data. We have invited the team to come out on patrols with our deputies, so they've actually ridden the train, watched how our deputies and security assistants actually perform their duties, saw the rigors of that task, saw how we have to patrol the system while allowing people to move freely and quickly through the system. In the early work, we've noticed that enforcement personnel using trust routines are getting a better detection rate and actually interdicting fare evaders at a higher rate. We hope to use this understanding to build the algorithms that will support the trust rollout to address serious crime, such as robbery, cell phone theft, assaults against persons, and ultimately to help us deploy our counterterrorism units.
Today, Armor is being used for optimal randomization in many ways. At airports for checkpoints, at harbors for boat patrols, for federal air marshal assignments to protect commercial flights, and for transportation security, becoming a signature tool of the corresponding protective agency, with each deployment of Armor customized for the security risk at hand. The impact of all the iterations of Armor has been noticeable, and the testing and development phase continues as the research team and our law enforcement partners make refinements to the system. Create is proud to discover another useful application for Armor in the pursuit of the security for our nation.